Hello students. So today we are going to discuss about the next video that is in this electric potential and capacitance chapter, that is regarding the concept of electric potential. Okay, our video on this today right now we are going to discuss mostly about the electric potential only. Okay, in the previous one, if you remember, we have discussed regarding electric potential energy, electrostatic potential energy we have discussed. So we are going to continue from that part itself. Okay, so just fasten your seat belts and then we will move on to this particular concept now. Okay, yeah. So firstly, it is regarding the electric potential. If I have to explain you something over here, that is, for example, if you take, like in the previous session, if you remember, we have discussed regarding, suppose if there is a charge q and at an infinite distance there is another charge q naught. Okay, so to bring this charge from this point and to place it here, okay, we are doing certain amount of work. Okay, we are doing certain amount of work there. Okay, to bring this charge from infinite distance to a point or which is at a distance of r, from that we are doing some work. And what is that work we have given there? W is equal to 1 by 4 pi epsilon naught. It is q into q naught divided by r. That is the work done that we have discussed in that electric potential energy, or that work done only, it will be coming in the form of electrostatic potential energy between the two charges. Okay, so with this base we are going to discuss it here. Okay, remember this, that is, some work is done in bringing this charge q naught from an infinite distance to a distance of r in front of that charge. Okay, right. Next, so for example, let us assume there is a charge, a positive charge, okay, whose magnitude is q. Okay, whose magnitude is q. Now let us assume at a certain distance r from the charge q, let us imagine that there is a point over there. Okay, so now whatever that work is done in bringing that charge from infinite to that point, okay, from infinity we are bringing a charge and we are placing it here. Okay, and what is that charge? We are calling it as q naught. Okay, so from that, what is meant by this actually electric potential means it is work done in bringing that charge. Okay, you are doing some work in bringing charge from infinite distance to a point here. That one we are calling it as W. And which charge we are bringing, my dear? Q naught. Okay, so what is meant by electric potential at this point is, it is equal to V is equal to W by Q naught. Okay, so already if you remember, I gave one formula for the W, that is this formula, right? So here V is equal to W by Q naught. If you take there, V, electric potential, is represented by the symbol V. W by Q naught, if you take it there, what is that W? 1 by 4 pi epsilon naught Q into Q naught divided by R, divided by, and what is that Q naught there? If you write it here, Q naught and Q naught will get cancelled. What do you get there? 1 by 4 pi epsilon naught Q divided by R. Okay, so there are two formulas for that electric potential, that is V is equal to W by Q naught, and at the same time it can also be equal to 1 by 4 pi epsilon naught. So this 1 by 4 pi epsilon naught can also be written as small k Q divided by R. If you remember, this value is how much? 9 into 10 power 9 Newton meter square per Coulomb square. Okay, so that is what that value is. Okay, right, that you can write it here. Okay, So this formula V is equal to W by Q naught can also be written as V is equal to KQ divided by R. Okay, where K is that 1 by 4 pi epsilon naught value. Okay, Q is the charge, this charge. Okay, you have to be careful, my dear. Q naught is the charge which you are bringing from infinity to that point, whereas this Q is the charge which is giving that electric potential at this point. Is that okay? So, and R is the distance of the point from the charge Q. Okay, next. So what are the different properties of this that we'll see? So look at this electric potential, it is a scalar quantity. Its SI unit is measured in volt, or sometimes it is also given by joule per coulomb. Joule per coulomb. Okay, next. And its dimensional formula is m power 1. Okay, its dimensional formula is m power 1, L power 2, T power minus 3, I power minus 1. Okay, let us go to the next slide. So here few more points let us discuss regarding this electric potential. That is, the first one is regarding the potential due to positive charge, it is always positive, and the potential due to negative charge is negative, because if you observe, V is equal to KQ by R. If Q is positive, V will be positive. If Q is negative, V will be negative. The next point is in the direction of that electric field. Okay, electric potential will be always decreasing. Electric potential, it will be decreasing always in the direction of electric field. Next one is, now this electric potential, its value is taken to be 0 at what distance? At infinity it is assumed to be 0. Okay, and near positive charges it is positive, and near negative charges it is taken to be negative, and at the infinite distance it is taken to be 0. Next, so positive charges, they always move from higher to lower potential. Okay, and negative charges will be moving from positive charges, they are moving from higher to lower potential, whereas negative charges will move from lower to higher potential. Regarding this point, let us learn more in the upcoming parts. That is, there is something, another concept called as equipotential surface. There we will learn more about this again. Okay, so the next slide. So this is a numerical, my dear. Okay, what is that numerical there? There is a point charge of how much magnitude? 20 millicoulomb. It is brought from infinity to a point in an electric field. What is that work done? Minus 20 millijoule of work had to be done against the field. Then find the potential at that point. Is that okay? Look at this. Once again, you can read that question, or you can pause that video and then you can read that question once. Let us proceed into that solution. So there, what is that work done, my dear? Work done in that question, it is given like minus 20 millijoule. And what is the charge that is being brought from infinity? It is 20 millicoulomb. Then what is the potential at that point is the question. What is the relation there? V is equal to W by Q naught. So it is, W is given as how much? Minus 20. Milli means 10 power minus 3. Divided by charge is given as how much? 20 millicoulomb. So anyway, if it gets cancelled, you will be getting it as minus 1 volt. Okay, so here the point is not about how simply you got the answer. It is about understanding how to apply that particular question. What did they give in the question? That is a W. And which charge is given? The charge which is moving in the field that they have given. Okay, so it is equal to how much? W by Q naught. And what is the answer we have got, my dear? Minus 1 volt. Okay, so at that point where the charge is being brought, there the potential is how much? Minus 1 volt. Okay, let us move to the next slide. So the answer what we got for this question is minus 1 volt. Okay, next slide. So there is a charged particle of how much, my dear? 2 coulomb is released from a point where electric potential is 10 volt. Find the kinetic energy of the particle when charged particle reaches to infinity. So there is a particle of, or there is a charge of how much magnitude, my dear? 2 coulomb. It is released from a point where electric potential is how much once again? 10 volt. What is the kinetic energy of the particle when charged particle reaches to infinity? Okay. So for this, I'm going into that. So you can pause this and then you can go through the question once again if you want. Okay. So in that question, what did they give is, there is a charge of how much magnitude? 2 coulomb. It is initially at what potential? It is at 10 volt. Okay. Now it is being left. It is actually going from one point to another point. What is that second point? It is at infinity. What is the potential at infinity I gave? It is a 0 volt. The question is, what is the kinetic energy acquired by the particle at that infinite distance? It is at initially at 10 volt point. From there it went to infinite distance. Okay. There, what is the work done, or that what is that increase in kinetic energy is the question. V2 will be 0 here. Okay. Right. Now, so basically V is equal to W by Q naught we'll write. So from this, what is that work done? It is equal to V into Q naught. This, like this we can write it. But if a particle is moving from one point to another point, we can write it as potential difference multiplied into Q naught. So what is the potential difference here? Work done is equal to 10 minus 0, and what is the charge, my dear? 2. So it is equal to how much? 20 joule is the work done. So according to work energy theorem, okay, what is the relation between work and as well as kinetic energy? The both are equal. Work done is equal to change in kinetic energy. Here if initial kinetic energy is 0, then what is that? Change in kinetic energy, it will be equal to 20 joule. Okay. So the answer will be kinetic energy of that charge will be equal to 20 joule. Okay. So try to understand. For example, if it is going from one point to another point, what is the work done in moving from that one point to another point? It is delta V into Q naught. Is that okay? Right? That's the answer for this. Next one. The next question. Yeah, see that next question. It is calculate potential due to a charge 5 into 10 power minus 7 coulomb at a point P located at how much distance? 9 centimeter away. There is a charge 5 into 10 power minus 7 coulomb, my dear, and we have to find the electric potential at how much distance? 9 centimeter away. And also we have to find the work done in bringing that charge 3 into 10 power minus 8 from infinity to that point. Okay. So look at this. You can pause this video and then you can go through the question. So what it is mentioned in that question, it is, there is a charge Q is equal to how much? 5 into 10 power minus 7 coulomb. They are asking what is electric potential due to this charge at a distance of 9 centimeter. Okay, let us find that first, then we'll go for the next part in that question. Generally, if there is a charge Q, it is producing some potential there, means what is that formula? V is equal to KQ divided by R. Suppose if charge is moved from one point to another point, we write it as W by Q naught. So K is equal to 9 into 10 power 9, charge is 5 into 10 power minus 7 by R is how much? 9 into 10 power minus 2. 9 cancel. So it will be how much? Minus 5. Okay. 5 into 10 to the power of 9 into 10 power minus 7 plus 2, which is equal to 5 into 10 power 9 into minus 7 plus 2 is minus 5. So this is 5 into 10 power 9 minus 5, which is equal to 5 into 10 to the power of 4 Volt is the electric potential. Oh, so huge value. Okay. At that distance of 9 centimeter, what is that electric potential there? 5 into 10 power 4 volt. Now in the same question, they asked another one. That is, what is the work done in bringing? What is the work done in bringing a charge of Q naught of how much it is? 3 into 10 power minus 8 coulomb. Okay, let me see it once whether this value is correct or yes, the value is correct. So already we got it as 5 into 10 power 4 volt. Then what is the work done? Just now we have discussed V is equal to W by Q naught. Then what is W from that? V into Q naught, which is equal to 5 into 10 power 4 into Q naught is how much? 3 into 10 power minus 8, which is 15 into 10 power minus 4 joule is the work done in bringing the charge from infinity to that point. Is that clear? Right? Take it down, all of you. Sorry, got used to my class. Okay, right. Next. Okay, the next one, it is, for example, instead of only single charge, if there are multiple charges at that particular, in a particular system, okay, then the electric potential due to that multiple charges, it is simply the algebraic sum of the potentials due to individual charges. Positive charges they produce positive potential, negative charges they produce negative potential. We have to add those, we have to take the algebraic sum of all their potentials to find the electric potential due to multiple charges. For example, there is Q1, Q2, Q3, Q4. Okay, like this there are few charges. Okay, now due to all these charges at a point, if you want to find electric potential, then we have to take the electric potential at that point as it is a summation of individual charges. That is, V is equal to V1 plus V2 plus V3 plus so on. Okay, and here also in this case also, that is the electric potential at infinite distance, it is again taken as 0 only. There is no change in that. Is that okay? Hope you got this point. That is the, yeah, every charge will be having its own individual magnitude of charge and as well as magnitude of distance. So based on that, V is equal to V1 plus V2 plus V3 plus so on. Okay, next. So based on this, let us do a question so that you will get a clarity on what type of questions will be there in this. Okay, so look at that question there. Find the electric potential due to a system of 4 charges arranged in the form of a square of side A at its center. Okay, there is a square. Okay, there is a square and there are 4 charges at its corners. Okay, so what will be the electric potential due to this 4 charges at the center? Okay, so this is just for an understanding purpose only. Look at this carefully. So let us assume there is a square. Okay, and at each corner there is a charge 1, 2, 3, 4, and let us assume that the distance between, that each side represents a length of r. Is that okay? Then question is, what is the electric potential at the center? Let us take all these charges. One is as Q and other one is Q, other one is also, this is minus Q and this is plus Q. Is that okay? So look at this carefully. What will be this distance? Actually it's a square, right? This is R, this is also R. Then this overall length will be equal to how much? Root 2R. In that, if you want to find half of that, that means this distance, it will be equal to R by root 2, my dear. It will be equal to how much? That is root 2R divided by 2. It is equal to how much? R by root 2. Okay, so based on that, look at this. So the electric potential at the center of the square, it is equal to potential due to first charge, potential due to second charge, plus potential due to third charge, plus potential due to fourth charge. What is the potential due to first charge? It is due to the charge, no? So we will take it as kq by, what is the distance from the charge to center? It is r by root 2. Similarly, for the second charge also it will be the same distance because it's a square. There also it will be kq by r by root 2. And then there is a third charge again here. What is the third charge? It's a negative charge, so it is minus kq by r by root 2. And the fourth charge again, it is how much? Q. So this is kq by r by root 2. Anyway, positive and as well as negative will get cancelled. So it will be root 2 also, if it goes up, it will be 2 times of root 2 kq divided by r. That will be the net electric potential at the center. Okay, my dear, this is only as an example. They didn't mention that this is always minus q like that. Okay, just for your understanding purpose, how to solve this model question only, I have given this particular question here. Okay, so let us go to the next one. So let us go to the next question. Okay, so here there is a ball of mass 4 gram and what is the charge? 2 microcoulomb of charge. It is released from the position where potential is 60 volt, and then find its speed when it reaches the position where potential is 20 volt. We have to find the speed. Okay, right? So already we have done some similar question like this. Okay, we'll do it once again. Okay, so you can pause this particular video and then you can see that question there. Okay, I'm proceeding with the solution there. Okay, right. So these are the values that are being given in that particular question there. Okay, we have to find what is the velocity there. Okay, what is the velocity attained. Okay, so we have already discussed that work done is equal to, when it is going from one point to another point, potential difference into the charge moving. It is equal to, what is the potential difference? 60 minus 20 into, what is the charge moving? 2 into 10 power minus 6. It is equal to how much? 40 into 2 into 10 power minus 6. It is equal to 80 into 10 power minus 6. That is 8 into 10 power minus 5 joule. Right? So this is the work done. But at the same time, work done is numerically equal to change in kinetic energy. Okay, initially let us assume that at 60 volt its kinetic energy is 0. Right? So work done is equal to half mv square. So it will be 8 into 10 power minus 5 is equal to half into, what is the mass? 4 into 10 power minus 3 velocity square. Okay, 2 will cancel this 2 times, 2 will cancel this 4 times. This, if it goes there, v square is equal to 4 into 10 power minus 5. 10 power minus 3, if it goes there, it will become 10 power plus 3, which is 4 into 10 power minus 2. So v is equal to how much? 2 into 10 power minus 1, which is 0.2 meter per second. That is the velocity of the charge on moving from the voltage of 60 volt to 20 volt. Once again, what we have done, work done is equal to change in potential into Q naught, or potential difference into Q naught. That work done we have to equate it to change in its kinetic energy by assuming that initial one I have taken it as how much? 0. Is that okay? So that is what this particular question is. Okay. Next. So that is about the video of this particular electric potential concept, my dear. Okay. So yeah, few more concepts are there in this electric potential that gradually for the next upcoming videos you can go through it. Okay, so that's what. So please don't forget to like, share, and as well as subscribe to this channel, so that daily we'll have some interaction about this particular concepts of 12th class and as well as 11th class, which will be useful for NEET and as well as JEE exams. Okay, thank you, bye bye, see you again for the next video.